This conference will now be recorded.
Right, so what's the main difference between list and a set?
Duplication.
Duplication, right?
And
Sets have unique,
unique.
list has duplicates, right? So today let's see how set makes this whole duplicate, the whole uniqueness feature. All right, so list and set are a group of single objects. Okay, so you have a single group of object like this. Okay, whereas map is a group of key and value pair. Okay, so something like let's say you store. Okay, so let's say you store like this, a group of object that has only students user ID or registration ID, what do you call it? Okay, so these are the group of students registration ID, student ID, and these are the group of those student names and so on. Okay, now what map does is map allows you to merge both of this. Okay, the only difference being this part has to be unique, the key has to be unique. Okay, so you can store all the keys in one place and all those values associated with these keys in another place. Okay, so thereby this map allows you to have a lookup and retrieving feature. Okay, map allows you to have a lookup feature. So if you want what is the student's grade whose ID is 5, you can just go here and get the value for that student grade. Okay, so map allows you to store key value pairs, set allows you to store unique, and list allows you to store duplicate. So let's see what is the set uniqueness nature all about. First of all, if I ask you to store the number 5, how do you check? Okay, just forget about Java or program or anything. You have group of numbers here, and I'm asking you to enter the number 5. Okay, now how do you ensure it is unique?
By checking with all the numbers we got.
You check with all the numbers, right? So you check with the first one. Is this the number 5? No. Is this number 5? Is this number 5? You keep checking everything, and if you find that there is already something called number 5, then you know that there is a duplicate. A 5, the number 5 already exists. Okay, so you can keep doing that. The worst case scenario would be, how many lookups do you have to do till the size of your collection? Okay, if your collection has like 10 items, what is the worst case scenario? You'll end up matching all the 10 numbers, right?
Yes.
And the best case scenario is you match the first one and you get a hit. Okay, so those are the best case and worst case scenarios, but this is not efficient really. Okay, as you guys know, this will take a lot of time. You have to compare whatever the new number you want to add, you have to compare that with every entry and make sure it is unique. Okay, now this cannot be done in an efficient way. So let's take another example. Okay, so imagine if this is a shopping market and there are different sections here. Okay, now if I ask you to look for mangoes, where would you start looking at? When you enter the grocery store, I ask you to look for mangoes,
Fruits.
right? So how did you decide it's a fruit? How did you decide you have to look in this section?
Since we know mango is fruits and all the fruits will be in the fruit section.
Exactly. Okay, so this is what is more efficient. Imagine if nothing was labeled. There was no group associated in a grocery store. Everything can be found anywhere. Okay, wouldn't that be a mess? You have to search the entire Walmart store. Okay, you have to go to every aisle, every shelf, and every corner to find what you're looking for. Wouldn't that be messy?
Yes.
That's what this is. You don't know which category it belongs to, and you are basically looking for the thing that whatever you're looking for in every possible section. You're looking for that in every possible section. Okay, that's why it makes it more difficult. Just like this, rather than looking at every shelf of the every corner on the every aisle, you directly go to one section that you know you will definitely find the mango fruit. Okay, so here's what you do. First, you ask the question, what category does mango belong? Okay, first you find the category of whatever item you're interested in. Okay, then look for that category. Okay, so mango, we know it's a fruit. So when you when you want to find a category of mango, you know that mango belongs to the fruits category. Then what do? You just look for the section which only deals with fruit. Okay, once you find that section, what is the next step you do? Okay, now that you're here, what do you do here?
Search for mango.
You search for mango only in this section, isn't it? Only in
Yeah.
the fruits category section is where you search for mango. Okay, then you search for item. This is what makes it more efficient. Okay, if you're looking for a bread, the first question you ask is, what category is bread?
Bakery.
Okay, what category is bread?
Bakery.
It's a bakery category. So do you find a bakery category in here?
Yes.
You look for everywhere, and there it is. You found the bakery category. Now that you're in the bakery section, the next thing you do is find where is the bread kept. Okay, so you'll have all sort of items here: cake, pastries, and bread. Okay, so when you're looking for a bread, the first thing you do is check what is the category of bread itself. So bread is a category of bakery. Okay, so now let's look for bakery. Where is the bakery? Here. Now that you're in the bakery section, then you look for bread. Do I find bread? Finally, you found it. Okay, so it falls in three categories. When you're looking for an item, look for what category it belongs to. Okay, you're looking for mango. What category does mango belong to? Then look for that category. Okay, and in that category alone, search for the item you're looking for. And that's how the map and set works. Okay, so this part is unique, right? In the map, which part is unique, key or value?
Key.
As the name goes, key is the uniqueness. Okay, so this part and this part is exactly same. So first thing you need to know is the set is implemented by utilizing the map. Okay, set class internally utilizes the map class. Okay, so a traditional set would look like this. if map is a key value pair with keys and values, then set is also a key value pair where you have the keys and you have nothing here. Okay, set is also, so what Java founders did is, rather than coming up with this key algorithm, okay, to find out key or uniqueness, they came up with this algorithm. One is categorize and then search. Okay, so in Java, the uniqueness check, the algorithm is based on hashing algorithm. Okay, they call it hashing algorithm. So hashing algorithm technically has two steps. Find the category, and then in that category find, search for what item you're looking for. Okay, find the particular category, and in that category search whatever you're looking for. That's how the uniqueness happens. Okay, so rather than writing this hashing algorithm twice, because key set requires uniqueness and the key in the map also requires uniqueness, so why do you have to implement the same logic twice? So what they came up with is a key value pair for map. Okay, and set started using the map itself in a slightly different way. They store keys but values are empty. Okay, so there are hash set, linked hash set, tree set. Okay, so the hash set internally uses hash map. Okay, so there is a class called hash map. That's what hash set uses. Okay, if you're curious, you can check it out yourself. Okay, so this is the code for hash set. Okay, this is what the Java founders gave you, the hash set class. So inside hash set class, what do you see?
Hash map.
Hash map. So hash set is using hash map internally, but hash map comes in two flavors, that is key and value. Set requires only one part, which is the uniqueness part, key. Okay, so every set internally has a map inside it. Okay, so if the second category is linked hash set, what is linked hash set using internally?
Linked list and map.
Hash set uses hash map. So linked hash set uses
Linked list and map.
Link hash map.
linked hash map. Okay, first of all, you don't mix list here. List is a totally different beast. Okay, list is all about duplicates and everything. Would you like to mix the duplicate concept into uniqueness concept? Does that make sense?
No.
No. So you wouldn't do that, right? So linked hash set uses linked hash map. Hash set uses hash map, and the tree set uses
Tree map.
tree map. Okay, so that's how technically all the programs are internally implemented. Okay, okay, tree set uses tree map. Okay, hash set uses hash map, and so on. Okay, so that's how internally set is implemented. So if set is using or relying on the map concept, you need to understand how map is implemented. If you know how map is implemented, then you will know how set is working. Okay, so set is internally using a map. So if you want a hash set, what it does internally, it uses a hash map. If you want linked hash set, it will use linked hash map. Tree set, tree map, and so on. Okay, So let's come back to the programming aspect. How does this ensure, how does this uniqueness that we learned, you know, 2 steps: find the category and search for that item in the category. If you're looking for mango, mango belongs to fruit category. So find for the fruit category first. Once you find the fruit category, inside fruit section, you will look for mangoes. Do you have mangoes here, here, here? Yeah. Okay. So categorization and then search. If you do only search, it will be time consuming. Okay. If it was only search, you'd start from here: mango, 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 mango. You'll search everywhere because you don't know where mango is kept. But if you know the category, you can directly go to that category and just search here and not the entire store. Okay, so search algorithm depends on category and search. Okay, 2 steps. So let's see how do we do that from a code point of view. Okay, so I have a student class which has 3 things. Okay, every student belongs to a certain grade, grade 1, 2, 3, like that. And every student has a unique student ID, you know, the roll call, registration, whatever you say. And then every student will have a particular name. Okay. Now, all right, so what I'm going to do is I'm going to create a hash set of student. Okay. So I want to create a group of student collection. Okay, so the student A grade is 1 and the student ID is 1 and student name is John. Okay, that's what the first student object has. Okay, the first student object has the grade as 1, ID as 1, and name as John. Okay, so let's create 3 profiles. Okay, we'll create 3 profiles. All right, so are there any duplicates here?
Yes.
Yes.
Which ones?
Grade, name, and student ID.
A and C.
A and C, 2 variables. Okay, so Shrestha, this is a variable name. It's not a duplicate. Just because I'm repeating grade, student, and name doesn't mean it's a duplicate. They are variable names. Okay, so you created 3 objects. Every object will have grade, student ID, and name, isn't it? These are instance variables. Okay, what is grade, student ID, and name? These are instance variable. Instance variable means what? Every object you create, they will have its own copy of grade, student ID, name. That's what instance variable is. Class variable means it is shared among all the objects. Guys, please revise everything in the past. Okay, all right, so the grade, the values are grade is 1, student ID is 1, and name is John. Okay, the second student also has student ID 1, but if you carefully notice, the grade is 2. So can you have the same student ID in 2 different grades?
No.
In 2 different grades.
Yes. Yes, we can have.
In the same grade, in the same class, can you have same student IDs?
No.
You cannot. Okay, so here in the same grade, you cannot have another student ID as 1 and name as John, another student ID and name as John. Okay, here this is okay. Why? Is the student ID and the name John, are they in the same class or different classes? I mean,
Is
same grade or different grade, school-wise?
different grade.
They are in different grades. So is this object conflicting this one? Is this considered as duplicate?
No.
No. Okay, but A and C are considered as duplicates. Okay, now what we will do is we will add A, B, and C. Okay, before you do this, just take a simple example. What will it print here?
Okay.
It's a set.
Oh. Oh, it's a set. So print 2.
So first question is, what is the difference in this and this? What is the difference in this line and this line?
The data type only difference.
Data type is different. Here you're storing integers and here you're storing students. So did you write the class integer yourself or did it came up with the JDK library?
Came up with the JDK library.
So how about student class? Did you write this or did that came with JDK library?
We wrote that.
By ourselves.
Okay, how did that come with the library?
We wrote the student class.
We wrote this class. So did that came from JDK library or is it user defined? Our developer defined program.
It's developer defined.
We created this class ourselves, isn't it? Just now. So this
Yeah.
did not came from JDK library. It came from us, the developer. Okay. So the difference is one is a set that utilizes JDK library class integer to store group of numbers, integers, and another came up with a group of objects, group of set objects that uses developer defined or user defined class. This class was written by us and this class was written by JDK library. There is a difference. Okay, so the rule is, if the group of objects that you are storing was written by you or was not part of JDK library, if you're storing any program that is not part of JDK library, you have to take certain measures. Okay, it could be anything. It could be a group of product object. Okay, it could be a group of product object or student object or bank account object. Aren't these all classes written by us? Product, student, bank account, Nissan, car. Didn't we write these programs?
Yeah.
So the rule is, if you use one of the user defined classes, you need to take measures. The measures are, for a uniqueness, what are the 2 steps you need to do for uniqueness check? For uniqueness check, I just explained you what is the 2 simple step. Forget about Java program. Generally, if you're looking for something, how do you do that?
Compare it.
Compare with what?
The rest of the object.
Category.
Category.
Search.
Okay, so remember, it is not just comparing. The whole point of this was, if you just compare, it will take longer to search. If I ask you to look for mango, and if you just look for mango, it will take longer to search the entire store. So what is your, in subconscious, what do you do? Without even knowing it, without even nobody telling you, don't you look for the category for that first? Yes or no?
Yes.
In that category is what you search, is what you compare, isn't it?
Yes.
So what is the algorithm for searching? What is the 2-step in algorithm for searching?
Category and search.
Category and search. Do categorization and then search in that category. This 2-step. Okay, so if you're storing a user defined class such as student or product, okay, if you own this class, isn't it your responsibility to write the code for categorization and search?
Yes.
So that's what you do. Okay, so there are 2 methods called hash code and equals. Okay, hash code is what categorization does. Equals is what meant for search or compare. Okay, hash code and equals. These are the 2 methods that you need to write for the uniqueness check. Uniqueness algorithm is based on these 2 concepts. Find the category of the student object and then search for that student object. Okay, we didn't have to do that with the first object because integer, we didn't write the code for this, isn't it? We didn't write the code for integer. How about string? Okay, how about string? what will be the size here?
2,
2. What will be the size here?
2,
Now, this is a collection for string. Okay, so you can add items that are
String.
Okay, if this is a collection of string, you can only store string. If this is a collection of integers, you can only add integers. Okay, remember that. Now here is the thing. When you add an item, you can have a literal value, or okay, when you're calling a method and it takes string input, what are the two ways you can pass that value?
the variable of same data type.
Yes, you can pass a variable of same data type or a literal value of same data type. Okay, so here this collection is for string. So what are we passing to the add method?
String.
Is this a variable or a literal value?
Literal.
It's a literal value. So you can pass a literal value like this, or you can create a string and pass a variable. Okay, remember the concepts that we learned before. How do you pass input? Okay, the add method in collection requires you to pass whatever data type you declared here. So if this is declared as string collection, it can only accept string. Okay, if the add method requires string, you have two choices: pass a literal value string or pass a variable which is of type string. You have two choices. That's why I was insisting, understand how methods are called. Now here, this is a collection of integer. So add method will take what?
Integer.
Integer. So I can pass either literal value 10, and what is the other choice?
Int a equals to 10, something like that.
This is your second choice. If the add method in the first collection takes integer, you can pass a literal integer, or you can pass a variable which is of type integer. You have two ways. Okay, so same thing we did here. Now literal value only applies for two kinds. What are they? Among primitive data type and objects, who has literal values?
Primitive and string.
Yes, primitive, all primitives have literal values, and in the object category we have string. Okay, string can have literal values. Okay, if I ask you to initialize, again guys, I'm repeating this. Okay, we did this in variables chapter over and over and over again. Revisit them unless you guys revisit that, unless you guys understand that, nothing will make sense. I won't be repeating this again. Okay, primitive data type allows you to initialize with literal values. Object, among objects, string is the only one which allows you to have literal values. When it comes to any other object, only way you initialize is by new. Okay, you use new operator for initializing every object except string. Okay, so the all student variable is of what collection data type?
Student.
Student. So the add method will take what?
Student variable.
Student variable. So why am I writing A here?
Adding for student A.
Because A is of type student. Okay. If this add requires student, you can only pass a variable which is of type student. B, student. C, student. In this collection, which is of hash set student type, can I add D?
No,
Why not?
because it's a string and
We have not initialized the student class.
What initialize?
it's because of data type.
What is the data type of D?
String.
And this collection, all student, what does it store?
Student.
Student. So is student class same as string class?
No.
No. So how would this take accept D? D is not a student class. D is a string variable. It cannot accept it. It did accept A, B, and C because C, B, and A, they are all data type student. All right, so that's what the collection is. Okay, now let's print their size. We have three categories. One set is of integer, another set is of string, and the third set is of student. Everywhere we are adding three items. One of them are duplicates. Okay, here the student object, we have A, B, and C. The C and A are duplicates. Okay, they have the same grade, same student ID, and same name. Okay, so C and A are duplicates. So we did the same thing. Add three items, and one of them are duplicates. So technically, this will print, the first collection will print the size as what?
Still
Second collection.
2.
And the third collection, technically, as a set, being unique and all that, it should also print 2. The first two found out what is a duplicate and ignored it. Made sure your collection is unique. The third one did not. So what's the difference in the first two and the third collection? First two gave you the unique collection and removed duplicates. The third one did not remove duplicates. So what's the difference between 1, 2, and 3?
It's user defined and inbuilt classes.
Integer and string are JDK library programs. You did not write them. Student, yes, you did write them. Okay, you wrote the class student. String and integer came as part of JDK library. So whatever came as part of JDK library, they did their job. They wrote the logic, the code required for categorization and search. But in your program, all you did is declare variables. Did you write any logic for how to categorize or search?
No.
Is there any method that writes the code of categorization or search? Doesn't. All it has is variables. You need to write the code for these two, hash code and equals. Okay, these are the two methods. Hash code typically writes the code for categorization, and equals writes the code for search or compare. Okay, these are the two methods that are basically used in collections to categorize an object and search for an object. If you do not have this, it cannot categorize and it cannot search. So if there is no categorization and search, it will allow you to store duplicates. So there are duplicates allowed because you did not write the code for categorization, hash code, and search equals. These are the two methods you need to implement if you really want that to work as a unique collection. Okay, you didn't have to do this for the first two collection because integer was not written by you, it was written by JDK programmers, and they wrote the code for hash code and equals. Even string program was not written by you, it came as part of JDK library, and they wrote the code for categorization and search. If you're curious, they wrote the code for hash code. The string programmer, JDK library, they wrote the code for hash code. They also wrote the code for equals. Okay, so this is the same syntax that I'm using in the student class now. Public boolean equals object as the data type, input as the object, equals method, boolean, public boolean. So I need to write the same code that the string programmers did for categorization and search. In other words, hash code and equals method. Okay, if you do not have this code, then your collection will not be unique. All right, so let's get into this. Imagine if you're storing this data of hundreds of students. What is the best way to categorize them? You have 100 students, and every student, you have this three information about them. What is that student's grade? What is their student ID? And what is their name? You know this three information about hundreds of students. How do you categorize them?
On the basis of their class, or like which grade they are.
Which grade they are, right? So in this three information, this is what you feel represents a categorization. Okay, if you're looking for a student John whose ID is 29, there might be so many student John in different classes, in different grades, right? So the first question you ask is, what grade does that student belong? That's how we categorize. Okay, if you go to a school and you're looking for some person, if you just tell that kid's name, John, the school will not help you. The first question they will ask is, what grade is John in? That's called categorization. So in this program, out of these three variables, we know that grade is the one thing that will define categorization. So what is the data type of grade? Integer. What is this method supposed to return?
Integer.
So that's it. Return grade. So if someone is looking for a category of a student object, we will return them the grade. Now just having the category, is that enough to find the item you're looking for? Category is one thing. Once you find that category, don't you have to look into that section?
Yes.
That's what we will do in the second part. Okay, so here what we do is compare my information with the other student object information. Okay, I'm going to compare my information with the other student object information. Okay, so first, object class. So one thing to remember is object class is the parent class of every single class that has been written or will be written in future. Okay, object is the root of every single program in Java. Okay, so there is a class called object. This is the very first class. It's the root of every class. Any program that you can think of, it's a subclass of object by default. And here is the thing, you don't have to write extends object. You do not have to write extends object. Every program that you ever write, by default, it extends object. You don't have to explicitly write like this. Okay, so test.java, who is the parent class of this class?
Object.
Object. Test unique class. Who is the parent class of this class?
Object.
Object. How about string?
Also object.
Okay, so that's clear. Every program that you ever write is a subclass of object. Okay, just remember that. Every program that you ever write is a subclass of object. So does anyone remember what is this sign?
It's overloading, overriding.
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 Overriding happens between same class or parent and child class?
It's parent and child class.
Parent and child. Okay, so if there is no extends written here, but still there is a sign for override, meaning what method, which class method are you overriding from?
From object class.
From object class. Student is a subclass of object. If you find a green sign like this, when you're not extending anyone, it means this method was part of object class that you are now overriding. Okay, so if you look into object class, there will be a hash code method here. Okay, if you look for equals, okay, so this two method, hash code and equals, you're basically overriding. Okay, you're overriding which class? java.lang.object.hashcode. Okay, even though you did not write extends, every program you ever write or will write in future, they are all subclass of this one main program, object. Remember that. Okay, so basically if you want the uniqueness check, you need to write the code for categorization and search. To write code for categorization and search, you need to override the object methods, the parent class object method, hash code and equals. You need to override them. Okay, since this is your program, you decide what is the proper way to categorize and what is the proper way to compare. Okay, all right, so if someone pass me a student object here, I will be able to accept it. Okay, so we did this runtime polymorphism. I'll quickly recap. If you want to call this method, okay, if you want to call this method, it requires a car parameter. So what can you pass here? Which variable can you pass here?
C.
C and N if N is an extension.
Yes, you can send two types. You cannot send string because string is not related to car. Is Nissan program related to car?
Yes.
So you can either send C or you can send N. Okay, you can send either the car object or any subclass of car object. Okay, you can send either car object or any subclass of car object. Similarly, here, when you're comparing two objects, you need to compare the same type. Okay, one student object can be compared with another student object. One product can be compared with another product object, and so on. Okay, so equal method takes object input, but what you need to do is typecast. Okay, first typecast it. Now you have two things. This is the other object you want to compare with your information. Okay, so what we do is, let's do that. This object's grade I will compare with another student's grade. This object's name I will compare with another student object's name. And finally, this object's student ID I'll compare with another student's student ID. So if all three matches, what does that mean? Does that mean they are equal or not?
Yes.
So I'll return true. If they don't match, then I'll return false. So search and compare. So my logic for searching is my information. Okay, in this class, whatever I have, grade, student ID, and name, I'm going to compare this with the other student object, grade, name, and student ID. Okay, if all three matches what this program has, then I will return true. Else I'll return false. So previously, this did figure out what was the duplicate. Our student class could not, because we didn't have the categorization code and comparison code. We didn't have these two. So now that we wrote it, now that we wrote the logic on how to categorize and how to search, let's try again. This time it did not allow the duplicate. Okay, whatever you had, student A and C were duplicates. Same grade, same ID, same name. Same grade, same ID, same name. A and C were duplicate student objects. It removed it. It was able to do that because you wrote the code for how to categorize and how to search. That is overriding hash code method for categorization and overriding equals method for search and compare. This is how you do the uniqueness check. this applies to both. Okay, this applies to both set as well as map. Okay, so in the map, which category is for uniqueness, key or value?
Key.
Key. So this is how you declare hash map. Okay, the map. K is for key and V is for value. Now let's say you're storing student ID versus student object. Student ID is integer, key, and value is student object. Okay, or just say I'll create a new class. All right, so here this is key and this is value. In place of key, I'm storing integer. In place of key, I'm storing integer. In place of value, I'm storing this user-defined class. Okay, in place of key, I'm storing integer. In place of value, I'm storing user-defined class. Which one has to be unique, key or value?
Key. Integer.
So key is integer. Value is student object. Key has to be unique. That's where you have to write the code for categorization and search. So do I have to write the hash code and value equals method here as well? The search and categorization?
No.
No.
Yes, you don't. You don't have to write the code for categorization and search in this class because the st class is being stored as value, not as a key. Okay, so the only time you need to write the code for categorization and search, that is hash code and equals, only time you have to write the code for those two methods is if you're storing them in a hash set and if you're storing them as a key in the map. Okay, if you're storing that in the hash set or any set for that matter. Okay, if you're storing this class st in a hash set, linked hash set, any set, if you're storing in a set, you definitely have to write the code for categorization and search. If you're storing that as a key, not as a value. Okay, if you're storing that as a key and not as a value, then also you need to write the code for categorization and search. Okay, only times you don't have to write them is if you're not using them in the set. Okay, if you're not using this class in a set and if you're not using them in a map. If you're not using them in the map as the key part, in that case, you don't have to write the code for categorization and such. Okay, the uniqueness only applies to set. Set requires everything to be unique. So if the item you store here is your program, user-defined program, you need to write categorization and search, hash code and equals. If the item you're storing in key in the map is also user-defined, there also you require hash code and equals. Okay, if you're storing this program, okay, if you're creating a collection of st class in an array list, do you need hash code and equals method in an array list?
No.
No, because array list doesn't require uniqueness. Okay, array list allows duplicates. So if you store this class in collection array list, you don't need hash code or equals. If you store them in vector, how about that?
No.
No.
No,
Duplicates.
because vector is part of list and list allows duplicates. If you're storing this as a key in tree map, if you're storing this class as a key in tree map,
Yes.
yes, when I say key, automatically it means uniqueness. If you need uniqueness, you have to write categorization and search. Anytime I refer to set or as the key in the map, that's it. That program has to write hash code and equals method. All right, so simple rule. When do we write hash code and equals method for a class? Okay,
When we need uniqueness.
right. If it is used in set or used as key in the map. These are the two special cases when you have to write hash code and equals method for your program. If your program is not used in these categories, then you don't need hash code or equals method. Okay.
Sure, I have a question here in the hash code.
Mhm.
Like, what if we have to return a value other than integer, like we have to category on basis of other value than integer?
Okay, very good. Now there are some techniques that you can come up with. Okay, take this example now. Okay, you have to be clever. You have to get clever with some way. Okay, let's say I have a class called grocery item. Okay, none of them are integers. Okay, none of them are integers. That's a very fair question. Okay, so I am creating a hash set for grocery items. Okay, this is the library provided class or user defined class.
User defined class.
We wrote this ourselves, so it is a user defined class. Yes. All right, so now So when I say add, only thing I can add is
String, category, name, and price.
wrong.
The glossary item variables.
Okay, remember guys, this is a collection for grocery item. So what can you add here?
Glossary item.
Grocery items. Don't say string, category, string name. How do you say that? This is a collection of grocery item. So are you going to add grocery item or are you going to add string?
Glossary item.
Okay, let's be clear about that. You cannot add category or name or price. Why is it failing? I did add your category string and name string. Why is it failing? You wanted category name and price, right? I added category name and price. Why is it failing?
The data type of all items is grocery item, and
All item is a reference variable of set grocery item. It's a group of grocery item. That's what all item variable is. If it is a group of grocery item class, what can you pass here?
grocery item.
You can only pass grocery items, nothing else. This is what you do. If this collection is a group of grocery item, you can only pass variables that are of type grocery item. You cannot say these. These are string, isn't it?
Yes.
This is a string. How can you add string when this collection was exclusively made of group of grocery items? You can only store these things. Okay. Now, when you create a new grocery item object, what is the value for category, name, and price?
Null.
Null.
They are all null, default values. So you added a grocery item object to the collection which has null values everywhere. So that's why before you add, make sure you put all the values as well. Okay. Now here is where you say fruits, mangoes, and all that. Okay. A dot category. What is the data type of category?
String.
It is string. So what is the value I'm assigning?
String.
String. This is where your string name price comes into picture. Okay, so once you create the object, everything is null. Default value is null. So make sure you set all the values, fruit, mango, price. So this is a proper way to create your grocery item, not with null values, with proper values. Only then add them to your collection, or else everything will be null inside. Remember that. Okay. So similarly, we will create 3 items. Then add B variable. Then add C variable. Now here, do we have any conflicts? Duplicates?
Yes.
Which variables are they?
A and C.
So technically size should give you 2 because these two items are in conflict. We have two items with the same category, same name, same price. Okay, so if I run this, it gives me 3. It doesn't give me 2. Okay, and the reason is grocery item is a user defined class, and when you store it in a set, it requires uniqueness check. Grocery item requires uniqueness check because we are using that in a set. So to ensure you have uniqueness, what do you do here? What code do you write?
Hash code and equal method.
Hash code and equals method. Okay, remember the syntax. You need to write exactly similar syntax. Now this is where DK it gets little tricky. Okay, let's call this parameter as other grocery object. Okay, hash code requires you to return integer. Okay, the only way Java allows you to categorize is by numbers. But here in this class, which data type do you feel better represents the group?
Category.
Literally variable category, right? But that is string data type. So I cannot say return category. Okay, I cannot say return category because category is a string class. And the return type for this method is integer. So if the return type is integer, you can only return variables that are also integer, which is not. Okay, there are two ways to fix this. Number one, string is a library, JDK library class. So do you know that string has implemented hash code and equals or not?
Yeah, it has.
It has implemented, because when you added string in your collection, right? When you added string, okay, when you added string in the collection, it was able to do that whole search and category. So if string was able to do the search and category, that means string has implemented hash code as well, isn't it?
Yes.
Yeah.
So you can say category dot hash code. So instead of you writing the code, just use whatever hash code the string program gives you. This is one way. Okay. Now another way is you come up with some your own understanding. In your application, what are the categories in your project?
Fruits and vegetables.
Fruits and vegetables. So do that check. If category dot equals fruits, okay, if my category is fruit, I'm going to return 1. Okay, else if category is vegetable, I'm going to return group 2, category 2. If it doesn't match, then category 3. Okay, so you have to get clever here. You have to decide how you want to define the category. If there is no data type integer which clearly allows you to categorize everything, then get creative. If category is fruit, I will return 1. If the category is vegetable, I'll return 2. So now you are coming up with your own numbers. You know that your shop is selling only 2 categories, fruits and vegetables. So what you decide? You will decide internal number mapping yourself. Okay, so the easiest way would be this, because we know category is a string class. and string class has the code for hash code and equals. So the easiest would be this, just to return the hash code from the string class. But if you want to get creative, you can do like this as well. For fruits, return 1. For vegetable, return 2. Everything else, category is 3. Okay. Now here, first thing first, whatever input you get, you need to typecast. Then if you want to compare your object with another grocery item object, you compare your category with the other object category. Compare your name with the other object name. Your price with other object's price. Okay. So when you say this dot category, you're basically referring to this one, your own category. So compare your category with another object's category. Okay, if these two are same and this dot name and this dot price okay, if all three matches, return true, meaning these two objects are same. If they don't match, then return false. Okay, now let's try to run it. We'll try to run with both the code for hash code. One with your own number mechanism, you convert every category in your own numbers, or use the hash code method from string class. We'll run with both. It excluded the duplicate. It still excluded the duplicate. So both the hash code are valid. Okay. In fact, even this is valid. If you look carefully, even this is valid. No logic, I'm just saying return 1. Did the duplicate go away?
Yeah.
So this is still valid, but it is not a good idea. Why?
Because it's searching the every every category. It's not
So
grouping.
basically every item in your Walmart grocery store, hundreds of thousands of items that you have, they all fall under only one group, which is group 1. So technically it will still work, but isn't it taking too long because there is no group mechanism? What you decided is every item will fall in only one category, group 1. Done. So technically it is still working, but is it efficient?
No.
No. Imagine if there was no groups. Okay, it might take a day or two. See, you have to go to Walmart every aisle, every shelf, and every corner and look for what you need. Maybe if there is no labels, vegetable, fruits, if there is no label in Walmart, okay, everything is everywhere. Whatever you're looking for, maybe it might take you an hour or a day or a month or a year. You will find it eventually, isn't it? But is that efficient if there was no labels? If everything is in just one group and no labels at all, if you want mango, you'll start with the first aisle, every shelf. second I, third, somewhere you'll end up finding mangoes. It will still get your job done, but is it efficient? No, because you have only one group and there is no categorization. That's what this is doing. When you say return one, it is still removing the duplicate, yes, but it is not efficient. You basically go and run the search compare with every single objects. Okay, this is still a valid hash code, but not encouraged. Clear?
Yes, sir.
So,
This conference will now be recorded.
do you need to implement hash code equal method anywhere for using this collection?
No, since integer is the key and it already has hash code and equal method.
Yes. So integer is the key, and integer is part of JDK library. You did not write it, so no need to write hash code equals anywhere. This will easily work. Okay. So just like for list and set, there is a method called add to add an item. For map, you require two parts, key and value. Okay. stu dot, here the method is not called add, but it is called put. Okay, you need key, integer, and value as a string. Again, these two are literal values. Okay, you can very well have variables. Okay, stu dot put a and name. Again, these are just basics. Here, what method are you calling here? Which line are we calling methods? Which
Line
line?
number 10
Yes, and
13. 113.
so we are calling methods in two lines, 10 and 13. Wherever you see parentheses, those are methods. So put is a method to add a new key value pair or to put new key value pair in your collection. Okay, the key is 10, value is John. Okay, if your collection takes integer as key and string as value, that's how you declared. You initialized this map collection with key as integer, string as value. So when you want to add a record in this collection, you have to put the same thing, integer as key, value as string. Okay, so here you can pass literal values if they are primitive data type such as int or a string. Okay, if it is not a primitive data type or string, while using collections, you have to create an object, set up the value in that object, and add that variable to the collection, the a variable to the collection. Okay, that's the key difference here and here. Here we are allowing literal values because int and string allows you literal values. Grocery item does not allow literal values. So you have to initialize like this, not like this, which is literal values. Okay. All right. So this is how we put items. Size will be what now? What is the size of this map?
2.
2. Key value is one record. 1 record and 2 record. 2. What will it print now?
2.
2. Here the key is 10. What is the key here?
8. 20. A is 20, sir.
A, which is
A.
20. Here the key is
20.
20 again. So aren't there duplicate keys? 20, 20.
Yes.
So duplicate meaning it will be excluded. You still get size 2 because keys are unique. Okay. What will be the size now?
One.
1. You added 1 record with key as 10. Added another record with key as 20. So we have 2 records with key as 10 and 20. This one turned out to be duplicate. So the size is still 2. Now when you say remove 10, this record gets removed. So the total size is 1. Okay. So just like in set and list, you have add and remove. In map, we have something called put and remove. Instead of add, we call it put. Okay. Let's see what other examples we have. Again, this code will work for every map. Okay, you learn the methods once, the put method, remove method, size, get, set, everything will work for all the classes. Okay, linked hash map, all the methods still works. Hash map, all the methods still work. Tree map, yes. Hash table, yes. Okay, now all the methods that you learned, put, size and remove, all these methods applies to every category of map. So you don't have to memorize different methods for different collection. Okay, learn all the methods for list and set category. Learn all the methods for map category and you're done. That's it. Okay, so when it comes to map, there are 4 categories. Okay, so let's make a list. All right, so these are the categories. Array list is good for what?
Dynamic reading, insertion, delete in the end.
Read, and if you want to modify at the end. Vector is good for
Data integrity and avoid corruption.
very good. Data integrity, the right word for that is synchronization. Through synchronization, you achieve data integrity. Okay, linked list,
Very fast editing.
okay. Now list, one thing is, main thing is duplicates and it is indexed. What is the main thing of set?
Unique.
Their unique key and value. Okay, this is a key value. Two values will be there rather than just one. This allows you to duplicate, they are indexed. This is unique. This is a unique key and value can be duplicated. Okay. Array list, read, modify, and hash set. The items are not indexed. They are unordered. Meaning, if you enter John, Jane, Ram, they can come out in any order. Okay, not at the same order that you inserted. Linked hash set is nothing to do with modify or anything. Okay, linked hash set main feature is it is ordered. What is the main feature of tree set?
Sorted.
Sorted.
They are sorted. Okay, so if hash set is unordered, hash map is also
And
this is ordered key value. This is
sorted.
sorted key value. Okay, these two have only one values. Map will have key and value. Tree map is sorted key value. We have one more thing in hash table. Okay, if you really notice, you have everything on the list and set. Ordered, unordered, sorted, everything is covered. Synchronized is missing in the map category. Okay, so hash table gives you that. This is synchronized, meaning data integrity. Okay, hash table is synchronized. So now you have every possible situation to cover. You can implement, you can literally have, you have the program for every possible scenario in one value, okay, which is list and set, and also in key value in the pair. Okay, every possible combinations you need for a key value data or just the value data. Okay, that's what they are basically meant for. They are unordered, ordered, sorted, unordered, ordered, sorted. Okay, only thing additional is hash table has synchronized features, meaning no two customers, no two program can make change at the exact same time. They have to wait until the other person completes. Okay, so among this, which one is the fastest?
Array list and
In the key value, in the map,
Hash map.
hash map.
hash map. Hash map is the fastest. Okay, linked hash map comes next, tree map comes next, and then hash table. It's in the order. Fastest, faster, faster, slower. Okay, this is slower because you already know it. If two programs are making changes to the same object, everyone else have to wait. Okay, I showed you here, right?
You give the
showed it on
example of
screen.
booking ticket in airline.
Yeah, I thought I did show you that in one of the spreadsheets. Okay. All right. So yeah, you guys get the idea. Synchronized meaning if two people are booking the seat at the exact same second, only one will be allowed to make change. The other customer have to wait. Okay, that will create more delay, more latency. Performance will be slower. Okay, hash map. But one thing, do you guys know why by default they are unordered? Could you guess why would map and set by default they are unordered? Isn't it easy to remember what order you are inserting? Why would they make it difficult? Look at this example. Okay, let's imagine you inserted items in this order: onion, then bread, okay. When you're stocking up, okay, when you're putting inventory to your grocery store, you bought inventory in this order: onion, bread, then carrot, okay, and then cake, mango, banana. You bought the inventory in this order, but when you stored it, didn't you store it in categories like this? What happened? Okay, you bought the items in this order, but when you stored, everything went in this category. Now, when I'm reading the items from the grocery, how would I list them?
Mango, banana, onion, carrot. Yeah.
So you inserted in this order, but when you're checking the inventory, you just go group by group and check how much mango, how much banana you have. So didn't they come out in the wrong order that you inserted?
Yes.
Right? This is the reason by default map and set are unordered. So by default, the fastest one is in fact the unordered one. Okay, fastest one happens to be unordered. Okay, if you really want to keep it ordered, like you want to remember how you inserted, then it takes a lot of additional effort. Okay, imagine this: if this is how you receive the inventory, every time you want to take a inventory detail, go to this aisle, onion, and check how much onion you have. The next item you received was bread. Walk all over to the next aisle, check how much bread you have. Then again go back all the way here and check how much carrot you have. So if you want to read in the same order, isn't it going to take time? Because you have, for every item you have to go to another aisle, come back. So reading, making it order is expensive when it comes to map. Unordered is faster. This is faster because what you do is, no matter how you receive the shipment, you just go from first category, check how much mango, banana, onion, carrot you have. This is much easier and faster. if you want to check the inventory in the same sequence that you received inventory, it will take a lot longer. Go here, go to another aisle, then go to another aisle, then here. That is expensive. So do you see why linked hash map is expensive than unordered hash map? Do you understand that?
Yes.
Right. So this is the fastest in terms of performance. It will give you result faster. This is slowest. Okay. This is one thing. Tree map is even horrible. Tree map, it is not just about storing the items like this in categories. You in fact have to pick the items in the alphabetical order. So look at this. Alphabetically, which comes first?
Bread. Banana. Banana.
So you get the inventory for banana, and rather than finishing mango, which is side by side, you have to go by alphabetical order. Walk all the way to the end of the aisle and check how much is bread. Then alphabetically next is cake. Then go all the way to carrot. Then onion is side by side, but you can't read it yet because your manager told you you have to read in alphabetical order. So even though onion is right here, you have to go all the way to mango and then come back and read onion. So isn't tree set also expensive?
Yes.
Okay. And hash table is the worst anyway. Okay, it will allow you that data integrity and all that thing, but it comes at a cost. Okay, the more people making changes to this thing, the more delay. If 100 people are trying to make changes to this object, 99 people will be put on hold because the one person has to finish its job. Only after the one person finishes the job, the second person gets the chance. So if you are the 100th person and every person spends 1 minute with this object, when will your turn come? After 99 minutes. After all the 99% before you have completed their job with this hash table, then your turn comes in. So you have to wait for 99 minutes. If 100 people are looking at this hash table, trying to book the same seat, this is the slowest. No amount of this tree map, linked hash map even is compared to hash table. Okay, but sometimes you need it. Sometimes you definitely need it if you want to ensure this data integrity is needed. Okay, so you guys understand the categories, which is faster, why, how, and what are their main features?
Yes.
All right, so now we saw how to add items, how to check the size of the map, how to remove. Let's see what else we have. Now get, you can get the value by its key. Okay, so for this example, if you want to see, okay, if you want to know what is the value for the first record, you need the key for the first record. So think about this like key and locker. You give me the key and I'll show you the contents of the locker. Okay, key, value. So if you need the value from the first record, give me the key of the first record. Okay, so you can say something like this, dot get 10. Get me the value of the key 10. Okay, the value is John. I'm printing the value for the key 10. Andy. For the key 20, value is Andy. So that's what the get method will allow you to do. Get will take the key and it will return you value associated with that key. If there is nothing, if there is no key called 30,
Null.
null. No value exists for the key 30, so null. Right, contains key. Contains key. Sometimes you might want to check if a key already exists, right? You can use contains key method. There is similar for values as well. You can get by value, you can check contains value as well. Okay, so let's see. Get or default. Contains key. So what will it print?
Null.
Okay, so contains will, when I say, is there a person called John in this class? What will be your answer?
10.
Is there a person? Yes or no is your answers. Yes, there is a person called DK. No, there is no person called DK in the class. So that's what contains is. It's a Boolean. So if you look for 30, it will either tell you yes, 30, a key called 30 exists, or the key 30 does not exist. True or false? False. What will it print?
True.
True. Similarly, you also have value. What will it print?
False.
Okay, contains key, contains value. All right, so the next part is how do we read a map? How do we read a map? Okay, so let's split that in two parts. If you want to get the value John, what do you need?
Key 10.
You need the key, right? So student dot get 10. Okay, if I know the key, I will get the value associated with that key. Okay, so here is the question. Forget about Java and everything and just tell generally. If this is a map, key and value. What is the best way to read it? You know about one method, get one. If I say get one, what will I get?
John.
I will get John. Okay, so if I say get two,
Jane.
Jane. So first step, what you do is make a list of all the key. Okay, if you have access to this, all the keys, won't you have access to all the values as well?
Yes.
Okay, so there are two steps. If you want to read a map, okay, get all the keys in one method call. Get all the keys. So when you do that, it will give you access to 1, 2, 3, 4, 5. Now that you have all the keys, what do you do next?
Loop.
Get of 1, get of 2, get of 3, get of 4, get of 5. What will these method call give you?
Values of those keys.
Values of those keys. It will give you John, Jane, Mike, Andy, ABC. So that's how you read a map. First, get access to the key, and with each key, call the get method. Each key, call the get method, and there you have it. Okay, so let's look at the code. Okay, this is your map that you want to read. Okay, this is the map you want to read. So this is the code to read that. Okay, so there is a method called key set. Okay, there is a map method called key set. So if you say key set, what you get is all the keys in a set. Okay, you get all the keys in a set. That's what step number 1 is. Okay, get all the keys in a set. So here is the question. If I want to get all the keys, it will be a group of what?
And this one integer.
Very good. Okay, because key here is an integer. So group of key here would be a group of integers. Okay, so if you see stu dot key set, what is this method returning me? A group of integers, because key is integer. A group of key is group of integers in this case. All right, so now that you have all the keys, do you guys remember how to read a set and list?
Using for each loop.
For each loop or iterator, either one of them. Okay, let's go with for each. It is a group of integer. So what do you do? Integer I. This is how you use for each. Okay, now in every loop, the I variable will have one key, the first key. In the second loop, the I variable will have second key. In the third loop, I will have the third key, and so on. Okay, so if I print this out, what will it print?
Ten and 20.
10 and 20. Okay, 10 and 20. Now, how do we read values, John and Andy?
Get I. Print
Get of
print.
I. That's it. stu dot get of I. This is giving you access to all the keys, and with each key in every loop, we are going to say get 20 Andy, 10 John, and this is how you read maps. Okay, 2 steps. First, get all the keys, and then using a loop, with each record, each loop, first key, get the first value. Second loop, second key, get the second value. Third loop, third key, get the third value. Fourth loop, fourth key, and the fourth value, so on. That's what we did here. Get all the keys using the method key set, then use a loop to read one key at a time. Okay, read one key at a time. In every loop, this S variable will have the first key, the second loop, second key, and so on. It's a loop. So pass that variable to the get method and you'll get the result in return, which is the value. That's how you read maps. All right, so just look at this chart and this will help you out in making a decision. Okay, which one you want to choose, array or one of the list categories or one of the set categories or one of the map categories. Okay, you can decide this based on these conditions. What do you want? You want faster performance, you want good reading, you want good editing, you want sorted, ordered, unordered, whichever you want this, whichever scenario you have a perfectly suitable collection class available. Okay, all you need is to memorize 5 or 6 methods. List and set, there are 5 or 6 methods. It applies to everyone, every single list class, every single set class. Even map, remove, put, set, size, key set, all those method applies to every map category. Okay, so you just have to memorize 5 or 6 methods and you're good to go. You can use it for any collections, any scenario. But the real trick is to know how they work internally. Okay, that's where your real test will be. But using these collections will be simpler. Okay.
This conference will now be recorded.
Okay, so I have 3 objects. Let's do simple. Okay, so here it takes integer and grocery item, value as grocery item. Okay, so this gives me error. It requires integer and grocery item. I'm passing integer and string. So what do I pass here?
A.
A is grocery item and the value should be grocery item. It matches. That's why no error. All right, so here we'll say B. Right, so when you say get, basically what do you get here when you pass the key? The value is
Get all the value from the key value.
So what's the value in this collection?
So for each key we will have the category, name, and price.
No, wait a minute. This is a map collection. I'm asking, what is the value?
Integer.
It will
No,
get
no.
the
Sorry.
value of grocery item.
Key value. If key is integer, what is the value?
Grocery item.
So when I say get and I pass integer, what will it return me?
The grocery item.
No, it will return the.
Okay, Rajan, do you follow why?
Yeah.
Okay. Key value.
The value.
When I say get and I'm passing I is integer. So in the get method, you pass integer variables, which we are doing, isn't it?
Yes.
So we pass integer to this collection. The value is what you get back. In this case, the value is
Grocery item.
grocery item. So if this method is returning me grocery item, how do you handle the return type?
Is a grocery item. So
Again, like I said, method calls, the basics, chapter 1. If the get method returns me grocery item, how do you handle the return type? Okay, that's why I was stressing on learning how to do method calls and handle the return types. So if the get method returns you grocery item, shouldn't you handle that in a grocery item variable?
yes,
Why is this giving me error?
since we assign string instead of grocery item.
Because the get method is returning what?
Grocery item.
And I'm assigning that to which variable?
String. Yes.
String. So can you assign grocery item to a string variable?
No.
This is what handling return type means. Now that you have the variable ABC, you can print everything. ABC dot category. Group 1, key 1, value fruit mango 10. Fruits mango 10. Second key, vegetable carrot 5. Okay, you have to understand, take the knowledge of everything that you learned. Okay, this is every single day. Okay? You understand the importance of how we do method calls, return type, declaration, initialization, right?
Yes, sir.
All right, so this is how you read if a value is a grocery item or any other object for that matter. So any other questions?
No, sir.
All right.